Okay.
So let's have a look here. Is there a particular place you'd like to start? You want to start with question 1?
Just one. Just question 1.
Okay. Which segment shows the distance between those two parallel lines? Bolton? Bolton, did I lose audio with you? Oh, man. Bolton, are you still there? All right, I will call you on the phone. Bolton, are you back?
Yeah.
All right, let me hang the phone up because I lost you there for a moment on the GoToMeeting audio.
Oh, yeah, no, I wasn't gone. I wasn't gone, I don't think. Well, I hope not.
Okay, so back to question 1. Which segment shows the distance between those two parallel lines?
Okay. Segment A.
Okay, why is it not?
As when it's asking.
Segment A.
As when it's asking for the distance. As when it's segment AB. As when it's asking for the distance between the two lines, there could be any different distances, but
no, not really.
Well, no,
what they mean is the shortest. They mean the shortest distance.
Yeah.
Why is
the distance is perpendicular?
Why is
so
CD
AB
not,
is perpendicular?
Right. Why is CD not the answer?
Because it does not show to be a right angle. It does not have.
Right.
Not
it
confirmed.
Looks like it's perpendicular, but they don't have that right angle sign there, so we don't know that it's perpendicular. So we cannot say that CD is perpendicular. And certainly EF does not look perpendicular, nor does GH.
H.
Right, but when they talk about the distance between two lines, they're always referring to the shortest distance.
Yes.
Always.
We learned that today.
Okay. Write the theorem that justifies the statement for number 2.
Okay.
J is perpendicular to K.
Let me get my theorem sheet out.
Okay.
Because I know it. I just haven't had time to memorize it.
I would almost rather you not refer to your theorem sheet. I have a reason for saying that. It's not the theorem that matters. It's the theory. Why is J perpendicular to K? Just answer that for me.
Because K is a linear.
No.
Because K is a linear angle, as we can see, and angles 2 and 1, the measures are equal to each other. They're congruent.
The reason.
So therefore,
that's the only.
So that would.
That's all you need.
Yeah, and K.
Angle 1 is equal to angle 2. They're a linear pair, which means they both must be 90 degrees, right? That's the only solution. There's no way one could be 91 degrees and the other 89. They have to be, in other words, this tick mark that you see here, this curvature line, what that means is that 1 is equal to 2. And we can tell they're a linear pair, so the only possible answer is that 1 has to be 90 degrees and 2 has to be 90 degrees, and that's what makes them perpendicular. Now, which theorem that is, I don't even know, and I don't even care. I mean, I know you need that. It's probably the theorem that says 90-degree angles are perpendicular or something like that. But like I said, knowing the exact theorem is not what's important. It just isn't. I don't care what your teacher is saying to you. 3 years from now, nobody will know that theorem, but everybody will know that if 1 is equal to 2, then you have J perpendicular to K.
Okay.
About number 3, why are angles 4 and 5 complementary?
Wait, give me a minute. Says theorem. Okay. Why are they complementary?
Yeah. Rather than citing the theorem, just explain it to me.
Okay. So if I don't know, if that angle is a right angle, and it is, we can confirm that that ray pointing up is perpendicular to the ray going to the right.
Correct.
Because it is a right angle.
Really, what this is?
And because
it's the definition of complementary. Yeah. That's all you need to say.
Yeah, and
definition of complementary. Yeah. If you have two angles that add to 90 degrees, which 4 and 5 do, then they are complementary. And that's all you need to say.
I do need to state my proofs, though.
Well, I'll leave that to you. And yes. The proof is that the definition of complementary means they add to 90 degrees. That's the theorem that you're going to that's the theorem you're going to use to justify that statement. Is definition of complementary angles.
Okay. Now, question 4. If two lines are perpendicular, then they intersect to form 4 right angles. Now, we know that the lines are perpendicular because there is a right angle marking that they are. Right. So we can confirm that all other angles, 1 and 2, are right angles.
Correct. And there is a specific theorem for that. That if two lines are perpendicular, then they create 4 right angles.
Mm-hmm.
Okay, how about number 5?
For us, it's just theorem 3.
What's that?
Find the measure of angle 1. So we can use that theorem to where if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. We can use that.
Okay.
And what happens, and by the definition of complementary angles, both the angles must add up to equal. By the definition of complementary angles and the angle addition postulate, we can infer that angles 1 and 65 degrees add up to equal 90 degrees.
Okay.
So 90 minus 65 equals 25 degrees. So angle 1 must be 25 degrees.
Notice that this problem does not require you to justify. It only requires an answer.
Yes.
So
yes, I know, and I just put the answer.
Okay.
But it said applying theorems. So.
Yeah, but the only thing it needs is an answer. 25 degrees. It should take about 5 seconds to come up with that.
Yeah, and for 6, 1 equals 90 degrees, vertical angles.
How about 7? 7 I can't quite see. I didn't quite get the full picture. Which angle?
Okay, so there are 2
here. Okay, so what's that angle right?
There are 2 perpendicular. Okay. So you see that angle 38, right? 38 degrees, right?
See,
well, then
if
the other
you give me the answer,
angle
you don't
1.
need to explain it. If you give me the answer, I know you'll know it.
Okay.
What's the answer?
That answer would be 40. That would be 52 degrees.
That tells me all I need to know. I don't need to know that you know the theorem or any of that. Is all I need to know is once you give me the answer, I know you understand the problem.
Okay.
Okay.
So 8. Explain how you would show that M is parallel to
Yeah,
N.
this is a little different. This is
Well,
going to require you to explain.
okay. So I can confirm from the corresponding angles postulate that we'll call T and N points that I don't know how to explain angles when they don't have any clear
Hold on a moment. Those are
title.
not corresponding angles. Notice. This angle that has the red square and this angle that has the red square, they are not corresponding.
Yeah, I know that. I know they're not corresponding. I know they're not corresponding.
All right.
But what I do know is that there are 2 corresponding angles in there. And then once I get that, because if...
Well, what you know from the information the picture shows us is that all 8 of these angles are 90-degree angles, correct? In other words, that one's 90, that's 90, that's 90, that's 90, that's 90, and that's 90.
So I get it. And from the corresponding angles converse.
Okay, that'll do. Not really, because they're not really corresponding angles. In other words,
No, I know.
Here's what you're saying. Here's what you're saying. If I had something like this, and you told me that 1 is equal to 2, now I would say, well, those 2 lines are parallel. In other words, this has to be parallel with that because 1 is equal to 2, and that's the corollary of the corresponding angles postulate.
Yes, and because all of the angles...
This is a little different. No. In this case, the 2 is down here.
Okay, but because all of the, because we know that all of the angles in there are right angles.
That's where you have to go. In other words, once you discover that there's right angles involved, in other words, the moment they tell you that's a right angle, well then you know that's right, that's right, that's right because of that theorem. And they tell you that's a right angle, therefore that's right, and that's right. And that means that this line is parallel to this line. Because at this point, you could use the corollary on most any of your theorems. In other words, now you really do have corresponding angles if I look at those 2 angles. They're both 90 degrees, so they are corresponding. You could also use the alternate interior angle theorem.
Angle is converse.
You could use the
alternate exterior angle converse.
You could use most any theorem that applies to parallel lines to prove that these are parallel. But it's not really correct to immediately use the corresponding angle because these are not corresponding angles. In other words, you have to first go to the theorem that says if you have a 90-degree angle, then that's perpendicular to both of those lines.
Well,
all right, how about number 9?
Okay. Number 9,
just explain it to me conceptually.
Okay. So since M and T are perpendicular, we can confirm that all of those 4 angles are right angles.
Not quite. How about if I draw it like this?
No, I said all 4 angles of M and T.
But these are only right angles because it says X and X. Well, the only
I'm saying
angles could be right angles or are equal angles as if they are both right angles.
I'm not saying that, though. I wasn't saying that X and X are right angles. I'm just saying that, you know how M and T are perpendicular. But all those 4 right angles, all those 4 angles
okay, so these
are right angles.
Okay, so those are all 4 right angles. All right. Okay.
Well, then we know that N is a straight angle. And from that we also know that 2x equals 180. That's an equation.
That's the key.
Then to solve that,
x is equal to
we divide 180 by 2.
And that means that is a right angle also. And now we have the same picture as we had in problem 8. We have a right angle there and we have a right angle there. That means those 2 lines are parallel. But the key to this problem is knowing that 2x has to equal 180.
I was never saying that the x's would equal 90 degrees to start with. I was just stating the facts that all those other angles above on the top line.
Okay. How about number 10?
Were right. Just give me a second. I'm writing this down.
Okay.
Okay. Number 10.
Uh-huh.
So, due to that postulate, where if two lines are perpendicular, then 4 right angles are created, we can get that all those angles are right, meaning they equal 90 degrees. Then using
the only thing you really need to say is that x is equal to 90 degrees. Once you have x to 90 degrees, we have the same situation as problem 8. Exactly. So however you proved the problem 8 that they're parallel, you can use exactly the same thing on problem 10. In other words, you know that x is 90, and if that's 90, that's 90. And now you have 2 right angles there. That means all 8 angles are 90 degrees, which means those 2 lines are parallel.
Okay. Explain how to draw 2 parallel lines using only a straight edge and a protractor. I don't think we ever learned this with a protractor.
Well, this is
only a compass.
Okay, well, I'll show you how to do it. There's you can draw that straight line.
Yeah.
And using your protractor, you could make a, let's say, a 60-degree angle, right?
Sure.
Now draw another line up here that makes that same 60-degree angle using your protractor.
Oh.
Now you know that these are corresponding angles and they're equal. Therefore, that line has to be parallel to that line. So all you really have to do is draw 2 identical angles.
Okay, let me write this down.
Okay. I'm trying to figure out the next one. I'm not sure I can. How would you fold a sheet of paper to create two parallel lines that are perpendicular to the same line? Okay. I think I know.
I think I figure it out. It's just, I think I know how to. It's just hard to explain.
Yeah, very hard. So those are two lines right there.
Yes.
And they're parallel.
Yes.
So if I fold the piece of paper right there.
In half.
Exactly.
And line the edges up,
and then,
up perfectly.
Right. That'll be a right angle. That'll be a right angle. That means all 8 of these angles are right angles. And I have two lines that are both perpendicular to the same line.
Sorry, yeah. So all you have to do is line up the paper so that fold the paper so that the corners line up perfectly.
Yeah, I would say draw two parallel lines and fold it on my dotted line here. In other words, if you fold it on that line, then you will have two lines that are both perpendicular to the same line. I think that's an explanation. That's kind of a tough problem there. I mean, by tough, I mean ambiguous. It's not, yeah. There's probably multiple ways to do it.
So many ways.
Yeah. Let's just go to the next.
Yeah, no.
Explain.
I'm still writing.
Okay, go ahead.
Okay.
How are your grades so far in geometry?
I didn't study for this one quiz, so I didn't do so well. But I've been studying now, and I've been getting much better grades on the quizzes, and that raised my grade up.
Do you still like Hansack?
Yansack?
Yansack? Yeah.
Yeah.
Good.
He's fine.
Good.
The thing is, people who have had him say drop him.
Yeah, I've had quite a few students who have had him and they don't like him. But usually they're students that are having problems. And so the first person they usually blame is the teacher.
He's a pretty strict grader, but that just means I have to work harder.
Yeah, that doesn't necessarily make him bad. I've never met the man, so I really don't know whether he's a good teacher or not. I have no idea. At this point, he's just going through the book. In other words, these problems that you sent me here are in my book also. And in fact, you probably didn't need to send me a picture. I could probably have found these problems. Let me just look real quick. 3-6. I think I have these exact problems. Well, maybe not. No, I don't. So I did need the picture. All right, how about 13? What's incorrect about that?
I'm still writing.
Okay.
Okay. 13. Y and Z are parallel. You cannot confirm wait.
Here's their picture. Why can I not say that Y is parallel to Z?
Because we do not know that X is perpendicular to Y.
Yeah, in other words, this doesn't have to be a right angle. Even though it looks like it in the drawing, you can never assume, unless they tell you, that all angles are right angles, unless they label it. In other words, this could actually be like 89 degrees, and we wouldn't be able to tell the difference by looking at it. And if that were 89 degrees, then y and z are not parallel. So the information that we need to confirm that these two lines are parallel would be another right angle in any of those four right there. In other words, I could draw the right angle there, I could draw it up here, doesn't matter. But if I at least state that one of these angles is a right angle, then I could say that y is parallel to z. But without that information, I cannot state that. That's why that's not, that's why that's incorrect. Okay. Now,
Okay.
okay, how about 14?
Okay, the distance from AB to point C is 12 centimeters. No, that is false because AC is not 90 degrees. It is not perpendicular to AB. It is 60 degrees. So therefore, it cannot be the shortest distance.
I could actually draw it so that it is.
Yeah.
That's 12, the way I've drawn it.
But it's not 12 centimeters because because segment AC is 12 centimeters, and that is certainly longer
Exactly.
than,
In other words,
it's not perpendicular.
they don't give us the measurement from C to B, and we cannot assume that it's an isosceles triangle. In other words, that's the picture we're looking at, and so this angle could be most anything. That could be 65 degrees, and it would not be an isosceles triangle, and this would not be 12. So unless they give us more information, we cannot tell that CB is the same as CA.
No, what they're trying to say is the distance from AB to point C is 12 centimeters.
Oh, so they're saying this distance right here. Yeah, you're right. They are. Because they're saying what's the shortest distance from the line segment to the point? Well, that's always a perpendicular distance.
Even if it's not, even if it's shorter by 0.000001 centimeter, then it's still shorter.
Right.
So.
And we do know that it's shorter. In other words, when they ask about the distance from line segment AB to point C, that's always implying that's a right angle there. And if that's a right angle, then there's no way this distance could possibly be 12. Has to be less than 12. In all right triangles, the hypotenuse is the longest side. So this distance here, which I'll call y, has to be shorter than 12, just like x has to be shorter than 12, because the two sides of a right triangle are always shorter than the hypotenuse. All right. You said you had some others that maybe you could verbalize?
I sent another picture, by the way.
Okay, cool. That's better, actually. Hold on a minute. Let me get to where I can bring it up. Yeah, our additions must be drastically different by now. I'm using a book that's about 7 years old, so I'm not surprised. But usually when usually the exercises at the end of the chapter don't change that much from addition to addition. But in this case, they appear to. All right. Problem 15.
Since it says in the diagram, line FG is perpendicular to GH, we can confirm that all those angles are supplementary and add up to equal 90 degrees.
Complementary, right.
Sorry, complement those up.
Okay, so give me an equation.
So if so 63 plus 14 plus x equals 90 degrees.
Okay, and then when you solve that, you get x.
And then you can combine like terms.
Yeah, so you get x plus 77, so x has to be 13 degrees.
Yeah.
And notice that that doesn't make that smaller angle 13 degrees. It makes it 27 degrees.
Yes.
In other words, they're asking you to solve for a variable, not that angle. Okay? How about the next? Number 16.
X does not equal 13 degrees. X equals 13.
Right.
Yeah, I made that mistake quite a few times.
Yes, a lot of people do. Where they give you, and you figure out what the angle is. We know the angle has to be 27 degrees, but that doesn't make x 27.
No, I know, but that doesn't make X have degrees either. It just makes it a number.
Yeah, you're right. X is 13. Yeah.
No, what I'm saying the mistake I made is putting the degree sign by the value of X.
Yeah.
When it's not just X.
I get it. I get it.
When it's like X plus 15 or 2X minus 5.
You're absolutely right. X is just 13. It's not 13 degrees. And then you have 13 plus 14 is 27, and then you have the degree sign. So the sum of those two are an angle that you can put degrees on. How about number 16?
Okay. So, yeah, basing off the same thing.
Yeah, basically the same.
FGH is 90 degrees.
Okay.
So 20 plus x minus 25 equals 90 degrees. Okay. So what I'm first going to do is I'm going to add 20. No, I'm going to combine like terms. Okay. And get x minus 5 equals 90 degrees. And just from that, you can mental math. But I'm going to do the equation. So x would have to equal 95 degrees.
Correct. Okay. Number 17, let's see if I can...
No, x equals 95.
Correct.
I'm fixing that.
Oh, that's what you said the first time. Number 7,
now
what equation can you write?
Okay. 2x minus 9 plus x equals 90 degrees. Correct. So combining like terms, 3x minus 9 equals 90 degrees. Then you subtract 9 from that. And you get 3x equals 81 degrees.
Hold on.
Now 81...
Hold on, stop a moment. Okay. What's the step after this step right here? You don't subtract 9 from both sides.
Sorry, you add it.
You add 9 to both sides. In other words, you always do the opposite of what it's doing. If it's subtracting, then you want to add. So 3x ends up being 99, and x is
11 degrees.
33.
Oh, I can't think today.
All right. I'd rather see you do these without a calculator anyway. So, all right, let's see. We have 15 minutes. Does the red circles, what does that indicate?
What?
I noticed there's a red circle around 19.
It means worked out solution. It doesn't
If
pretty
we
much.
can't do all of these and we could only do a few of them, we'd want to do the ones with the red circles, correct?
Wait. No. We have to do 21 next. 21 is our next question.
Oh, okay. Okay, so if C is perpendicular to D, which statement
Then
is true?
the measure of angle 1 plus the measure of angle 2 is equal to 90.
Good. What's the
So
next
A.
one to do?
That would be 26.
Okay. Find all of the unknown angles in the diagram. Justify your reasoning for both, for all.
Okay.
Okay,
So we know that angle 1.
Where do we start on 26?
Okay.
Which piece of information
Why don't we stop?
are they giving us that's the most important piece of information?
The fact that 1 is 90 degrees, right?
Correct. Which makes these two lines perpendicular to one another. And all four major angles are each 90 degrees. So that's a pretty good starting spot, because now you can figure out angle 2. What's angle 2 have to be?
Angle 2 has to be 60 degrees.
How about angle 3? Well, not yet. Well, what's angle 3?
Angle 3.
And why?
Angle 3 is 30 degrees.
Because?
Vertical angles are congruent.
Cool. What's angle 4?
That would be... Wait, give me a second. Vertical angles congruent theorem. Okay, angle 4 would have to be, since we know that angle 3 is equal to 30, and then we can add 40 to that, and then we subtract 40 from 90 because it's congruent to angle 1. We can confirm that measure 4 equals 20 degrees.
Okay. How about angle 5?
Angle 5 must be, it must be 90 degrees because vertical angles congruent theorem.
Yeah, there's a number of reasons. It's vertical with 1, but it also, the theorem that says if you have two lines that intersect that are perpendicular, you got 4 right angles. And angle 5 is one of those right angles. Now,
because of angle 2 being complementary with 30, we know that it must equal 60.
yeah, no, we already did 2. We did them in order. We did 1, 2, 3, 4, 5. So we're done with that. Do you have to do either 27 or 28?
Give me, let me see. I think the next one, yeah, 31 is the next one.
Okay, that's not on this page.
Yeah, I'll read it out to you.
Okay.
Because we have nothing left.
Okay.
Really. We have 2 questions left.
Problem 27 is an interesting problem.
Yeah. Okay, 31.
Okay.
Oh, wow. Yeah, that might be a good thing to send you a picture.
Yeah, I was going to say, it's going to be hard to verbalize any of these. We haven't
Because it's a whole proof.
verbalized.
Because question 31 is a whole proof.
Okay, go ahead and send it to me.
Yeah, I am.
See if we can get it done within 10 minutes here.
Okay, I don't think it's perfect, but it's readable.
Yeah, that's all I need.
Yeah. And the last question we have is 39, and that's easy. So.
Oh, you mean after the proof? 31?
I need to send.
Holler when you've sent it.
Okay. Got it. Send. Okay. I'm going to do 39 right now because it's easy and it won't take up space.
Okay. While you're doing that, let me pull it up.
But yeah. I don't even really need to explain it to you.
No, if you can do 31 on your own, that's fine. Proofs are good though. Proofs are tough. And this is a great way to teach proofs, this problem. You're talking about,
okay.
I guess this is 31. You're looking at the two-column proof, right?
Yeah.
The one you have to do. What's so good about this and for teaching proofs is that one of the columns is filled in already.
Yep.
So it makes it easier to do. In other words, if you had to do this whole proof from the start, that would be tough. But
yeah, no.
the fact that they've
on our last quiz, on one of our quizzes, we had to do a complete proof where we had to write every single step in.
Right.
And
those are definitely hard. But to learn how to do them, this is the way to do it, is to practice with a bunch of these. Okay. So let's start with number 1. They've given us both the statement and the reason. So let's go to number 2. 1 and 2 are supplementary. Why?
Let me write that down. Okay. Definition of linear pair, right?
Correct. Number 3. The reason is definition of supplementary. Therefore, what must 3 say?
That measures angle 1 plus angle 2 equals 180 degrees.
Yeah.
Measures of angle
measure
1.
of angle 1 plus the measure of angle 2
Angle 2 equals 180 degrees.
Right, because that's the definition of supplementary. And sometimes with these proofs, the most frustrating thing about proofs is that why do we need statement 3? We've already said they're supplementary. So sometimes it can be a little aggravating that you have to spell out the fact that the measurement of angle 1 plus the measurement of angle 2 are supplementary.
He's just doing this to make us think, really.
Well, no,
so we can get these
it's not just Yansack that's doing this. This is the way two-column proofs work. Everybody have to do this two-column proof the same way. I'm only saying that it frustrates people because a lot of these statements don't feel like they're necessary. In other words, this says angle 1 and angle 2, whereas 3 says the measurement of angle 1 plus the measurement of angle 2. There's a difference between angle 1 and the measurement of angle 1. Okay, so 4, they give you the statement and they give you the reason. That was a given. Angle 1 is equal to angle 2. Or excuse me, angle 1 is congruent to angle 2. Yeah. So number 5 says the measurement of angle 1 is congruent to the measurement of angle 2. What's the reason?
The reason is definition of congruent angles.
Correct. Number 6, they give us both the statements and the reason. And substitution.
Substitution property of equality.
Right. In other words, number 3 said the measurement of, hold on a minute. Seems to me that statement 6 says the same thing as what we had for number 3. Measurement of 1 plus the measure, no, excuse me. Statement 3 said the measurement of 1 plus the measurement of 2 was equal to 180. Well, statement 6 says the measurement of 1 plus the measurement of 1 equals 180, and that's due to substitution property. In other words, statement 5 tells me the measurement of 1 is the same as the measurement of 2. Therefore, I can substitute for the measurement of 2, I can substitute the measurement of 1 because of the substitution property. Number 7, they give you both the statement and the reason. They add those two same angles. And
I said combining like terms without even looking at it.
Yeah, that's okay. Yeah. Now, a lot of these reasons are, I mean, putting it in exactly the correct words is the hardest part.
It's filler. It's filler.
What about number 8?
It's filler.
Yeah, what's the reason?
Division property?
Yes, division property of equality. You're going to divide both sides.
Yeah. On these terms, division, addition, subtraction, multiplication, he doesn't care about the equality or congruence.
No, exactly. I don't either. And that's why I find these a little bit, that's why me and everybody else finds these a little bit trying. It's not that you don't know how to do them. It's you're not positive if you're using every single word correctly in the reason. What's number 9's statement?
Okay, wait. Measure of angle 1 is a right angle.
Or just angle 1 is a right angle.
Yeah. Sorry, I should do that. I should.
Yeah, angle 1 is right angle. Definition of right angle being 90 degrees. Well, statement 8 said that the measurement of that was 90 degrees. Therefore, angle 1 is a right angle. And finally, what we're trying to prove is that G is perpendicular to H, which is what the final statement always says, is what you're trying to prove.
And we can get this through the definition of perpendicular angles.
Yeah, or the corollary for two intersecting lines. I do remember looking in the book and seeing there's one particular theorem that is the theorem for when you have two intersecting lines that intersect at right angles, that or if they're perpendicular, then it creates four right angles. And the reverse of that is also
true. We get all these theorems.
Yeah, if you have four right
we get all these theorems
or one right angle, then those two lines are perpendicular based on that theorem.
No, but we get if one right angle is present, then four right angles are present.
Right.
We learn these. We get these theorems and these postulates from the book.
I know.
Just
yes,
let you know.
For sure you do. But also, just so you know, the numbers that they assign them in the book are not universal. If you went and got a different geometry book and opened it up, you'd get the same theorems, but they wouldn't be the same numbers. In other words, there's no universal
I know.
3.6. That's 3.6 in this book, but in a different geometry book, it might be 4.2.
Yeah, that's why I don't. That's why I don't use the numbers when I'm talking to you. I try to use the names.
You shouldn't. You shouldn't pay any attention to the numbers. Just maybe the name of the
I've used the numbers on my homework. Because I know he wants them.
Really? He does? Okay. That's picky, but that's fine. Okay.
Because he doesn't give a title. He doesn't give a title for every theorem.
Okay. Cool. Cool. That's the way I like geometry taught. It's not the
Yeah.
title. It's not the title that's important. Nobody cares about the title. What
Yeah.
really is important is the meaning of it. That's important. And
Okay.
that doesn't really depend on the title. The meaning is that if I have two lines and they're perpendicular, that means all four of those angles are perpendicular, or all four of those angles are 90 degrees. That's the meaning of that theorem. I don't care what it's called. I just know that if I have two intersecting lines and they form one right angle, they form four right angles.
I'm really happy because this is my only homework.
Oh, good. So you're done.
Yeah.
All right.
Because we had big projects today and yesterday.
Okay.
And
Well, let me run because I have your brother up next.
yeah,
Looks like he has.
for only 30 minutes. Right?
Okay, his phone is broken, so he wants me to email him the meeting ID. Okay, Bolton, I'll talk
Or
to
you
you
could
next
text
week.
me. Wait, you could text me and I'll tell him it.
Okay, hold on a second. I got to run it again.